So we want to rewrite this so it's an f of x over g of x, and then we can have, we could have a limit that's that allows us to use L'Hopital's rule, so we can evaluate the derivative of the numerator and the denominator. So to rewrite this, it's an exponent, a variable and an exponent, so that means we're probably going to need to use some sort of logarithm. And so let's help get that down by maybe doing e to the natural log of x to the 7x. A legal move because e to the power of natural log, those are inverses of one another. But what that lets us do is the 7x can come down and multiply. We could rewrite that numerator a little bit more. This is e to the power of do 7 natural log x over 1 over x. Okay, and then using our rules of limits, if you're trying to evaluate the limit of a constant that's being raised to a power that has variables, then you can just evaluate this limit. And that limit up here, the 7 natural log x over 1 over x, that's a candidate for L'Hopital's rule. So we can use, I don't know if this is the textbook quick-hand notation, but I use this to say that I'm using L'Hopital's rule. Taking the derivative of the numerator and the denominator, that's 7 over x for the numerator, and the denominator, that's negative 1 over x squared, right? Because the negative, this is like an x to the negative first power, so the negative 1 comes down and multiplies. And then not doing L'Hopital's rule this time. If we rewrite it, that's e, so this dividing of negative 1 over x squared, so flip and multiply. This is 7 over x times negative x squared over 1. So I flipped and multiplied. And that's negative 7x. The x's cancel out. Okay, and so that's a limit we can evaluate. The limit as x approaches 0 from the right. Since this is a constant in the base, we can plug in 0 into the numerator. We don't have any divide by 0 problems. This is just going to be 1. Because as x gets really close to 0, then you've got a number to the power of 0.